Hello and welcome to Learn Data. I'm Nilesh and today we are going to continue learn about pandas. In this video, we'll work with strings and we'll look at how we can change case of a string and how we can remove blank spaces either before or after a string, how we can handle NANs with strings in case of lists or series, and how we can concatenate the strings which are in a series or a list. So let's open Jupyter notebook and start coding. Here I've already created a new Jupyter notebook and imported 3 libraries. We probably don't need the matplotlib today. We need NumPy and Pandas. So we have these two, and let's go ahead and create a series first. So x is equal to pd dot series, and here we are going to use bunch of strings. So this is a sentence, and then we'll introduce a nan, which is np dot nan, and then add another string in caps is it. So that's our series right here. And if we now want to change the case of the letters that are in this series, for example, if you want to change the T to either upper or lowercase, it's already upper. So if you want to change it to lowercase, vice versa, if you want to change these to uppercase or this to lowercase, we can do that. So the syntax for that is we want to type x dot str dot lower, and this will convert all the items within that in that series to lowercase. As you can see, the T is reduced to lowercase and is it is also reduced to lowercase. Similarly, we can convert all the contents of that series to uppercase by typing x dot str dot upper open close parenthesis, and here we can see that everything now has become uppercase. Furthermore, we can use the length operator to check the length. So if we type x dot str dot length, we can get the length of each of these strings that we have within that particular series. So here, let's count this on the 1, 2, 3, 4, 5, 6, and that's why we have 6. So this is counting the space as well, because that space is also part of the string as it is inside that quotation marks right there. Now, what if we have a different type of series where we have blank spaces before and after the letters? So let's create another series here where we have a space on the left side of this string of this word called left, and then this one has no space. So the quotes, there's no space before or after that particular word. And then we have another word where there is space here after on the right side of the word right, and here we have space on the left side. Now if we were to look at this, here we cannot easily see where the spaces are, so I'm going to put this in a list and print it just so that we can see where the spaces are. Left has here, right has the spaces here. And if we want to remove the spaces on the left side of a particular string, what we want to type is x dot str dot strip. And so this, if we are doing on left side, we want to type l strip, and that way we remove the space on the left side. If we print this as a list, then we can see that the space on the left side is now removed. Similarly, if we want to remove the spaces only those that are on the right side, instead of l strip we want to type l strip we want to type r strip. And when we do that, here we can see that the blank space that was on the right side of the letter right, it is now removed. Moreover, if we are in a situation where we want to strip all the blank spaces, and that's what I have mostly done, is we want to remove all the blank spaces in strings, and to do that what we want to type is just x.str.strip, and that will remove all the blank spaces both before and after a particular string. Next, let's look at ways in which we can also use the exact same method to remove spaces if that those particular strings were indices. And we can create another index variable x idx, and let's call this pd.index. Now it has all the same contents because we use the x values set as index for the variable xidx, and now if we run all these commands we are going to get exactly the same result out. If we do print and type x.str.l strip here, and why don't we just copy all of these, that will make it easier. So I'm going to put this, copy 1 2, and let's put L here, S here, and we'll remove this, and we can see here that the output is the same. L strip removes the blank space that's on the left hand side of the string, right R strip removes space that was on the right hand side of the string, and then strip just by itself removes all blank spaces either before or after a particular string. And moving on, let's look at now how we can use the same method to remove spaces either in strings or variables from a data frame. So let's go ahead and create a data frame. Df is equal to pd.dataframe, and here we have one key, that is space, and we say parameter 1 space, and then here we can give it some values 1 2 3, and then we'll go ahead and create another parameter, so spelling parameter, and this is 2, and we can go ahead and add another set of numbers here. And when we run this, if you want to see how they look, this is how the data frame looks. And if we were to look at the df.columns, this is how the data frame's column indices look. So as you can see, we have a space before and after of both the column names, as well as we have a space in middle of the column name. And by far this was the most widely known issue that I've always was working with, and you get these files where the column names have spaces in them. Therefore this method would be applicable in those situations where in Python you usually do not want any spaces between column names or variables, so that, and we want to bridge that gap by underscore, and that makes it easier to handle those strings. So here we can say df.columns.str.strip. now when we run this, we can see that we removed all the blank spaces that are outside, either left or right of the string. We have not touched any blank spaces that are within a string, within these 2 characters right here. So that stays as is. Next, let's look at if we can change the cases of the column header. So if we do df.column.str, and here if you say lower, it will change all the cases of those column names to lower. And this again is most I have used it a lot, because whenever you have columns you want to bring them, all of them, into the same case, and lower case is generally preferred. So you want to bring all the cases to lowercase unless there is a particular significance of the case which needs to be maintained in that column. Otherwise its best option is to convert all of them to lowercase. And we can also go ahead and look at what we can do to change the case to uppercase, and columns, and here we can see that all the letters parameter in both column names are now uppercase. So so far what we have been trying is we are giving one command at a time and changing the string. What we can also do is we can chain these commands to see that all these changes are applied to that string and we get the final output. For example, now if you say df.columns is equal to df.columns, and now for this, first what we can do is strip all the blank spaces either to the left or right, and this is what we are doing. Once we get the output of that, now we say dot str.lower. What this will do is it will take the string that was generated by this command, which removes the blank spaces, and now it will convert all of them to lower cases. And once we have the output of that, we can go a step further and say str.replace, and here we can say replace the space in quotes by underscore within quotes. And when we run this and look at the df.columns, we can see that now we have a well-made column name that has taken care of all the blank spaces and also connected separated strings by underscore into just one string. And that's how we can use the strip commands and replace commands to modify the strings. We'll talk more about replace using regex regular expressions in next videos, but in this we'll limit this to just showing a simple replace command. Now how can we do concatenation? So let's concatenation of strings. Say if you have just a string, let's say A, and if you have a string B, and if you add A plus B, here you get a concatenated string AB. So that's the simplest way to do it. Now if we have a series, for example, let's say we have a series A is equal to pd dot series, and here we have items such as x, y, z in this particular series, and we can give this a data frame d type is equal to str, and let's look at how the series looks. So that is our series. Now if we want to join the items within this series, for example, if you want to join x, y, and z into a single string, how do we do that? So to do that, we can type a.str.cat, and that will join it into a single string. Okay, so this what we did is equivalent to saying str.cat, where we can specify the separator between the strings, and here we just say open close quotes without any space, and that will give the same output where these three are joined without any separators. However, there are ways in which we can also introduce a separator. So let's say we want to introduce a comma between these x, y, and z, so we can do that as well. So we need to specify the separator, and that's going to be within the quotes, and we can see that the string now has x, y, and z separated by commas, and that can be anything. We can also put a star there, and now we have x star y star z in that particular string. Moreover, we can use if in this particular case all the values in the series were good, there were no NaNs. But now what happens if we have NaNs in a string? How do we work with that? So let's create a series A again, where this has now NaNs. We have a regular x and y, and now we can introduce a NaN here followed by z, and again the data type is the same. We'll use the str as the data type for this items within this series, and here we can see that we have x, y, NaN, and z. Now when we are trying to concatenate the strings within this series, let's see what happens if we try str.cat, and when we run this we get xyz. The np.nan is completely ignored. Now it's even if we use comma separator, so let's try that str.cat, and if we say sep and then within quotes say comma, the nan value is ignored and if there is a situation where you have to preserve the that there was a nan there and replace it with some kind of another character, there is a way we can do that. And for that what we can do is type na underscore rep, that is replace is equal to underscore or just a hyphen. What this is doing, it's going to replace the na values with a hyphen, and when we run this now what we get is xy, and then for the nan we have a hyphen and then followed by the letter z that we already had. So that's how we can handle nans when we are working with strings within a series that need to be concatenated. Furthermore, let's see how we can work with multiple different series together. So if there is more than one series, how do we work with that? So we can go ahead and create our series again. Let's say a is equal to pd.series, and here we can keep our x, y, z, and let's add np.nn towards the end of this series and create another series b, where we have capital X, capital Y, capital Z, and capital Q. This does not have INN. So there's these two series that we have. And if we were to join this concatenate this series, we would type a.str.cat b, and what that does is it joined the X with the capital X, Y with capital Y, and so on. So this is what we get. However, in the last item we have nan, therefore both these items were converted to nan, so the q is gone, there is no q there. And if we need to preserve that item within that is associated with nan, and you guessed it right, we can use the na underscore rep. So what we can do is type a.str.cat b, and then na underscore rep is equal to, in open quotes we can say hyphen, and that's what we have now. The nan is replaced by hyphen, and now we have the q in the output. So that's one way to handle the nans when we are joining two series together. Moreover, if we save this particular series that we just joined into another variable, say m, and if we want to join our original series a which we created up here to this particular series m, we can do that in the same way. So we can say a.str.cat, and here we can say m comma na underscore rep is equal to again hyphen, and we can see that now we join this initial series x, y, z small with this particular series that we have here. We can also check the type. So if you type print type m, here we can see that that's also series that was returned, and when we concatenate those two we can get a third series which is combination of those two series put together. So far what we have been doing is looking at how we can concatenate strings based on the direct values that are with the strings. How about concatenating the series together using indices? Can we do that? So let's see how we can do that. We can use the same series that we have up above, a and b. So the a series we have is this. So what we are going to do is let's keep the indices the same for A, which look fine, 0 to 3. For B, we are going to shuffle this indices. So we'll say b dot index is equal to pd dot index with a capital I, and here we can say 3, 2, 0, and then 1, and just to change the sequence of those indices. So this was our earlier index 0, 1, 2, 3. Now we have changed it to 3, 2, 0, 1. So the x item now has index 3 instead of 0. Now if we are going to join this on index, what we would expect is that the index of 0 which has x should join with index of 0 which has z, and so the output that we get should have xz and not xx. So let's see if that works. A dot str dot cat b, and then here we can say join is equal to left, and by saying left, what we are saying is this is the series we are going to keep. All the values from here will appear on the, and they'll be also on the left hand side. So when we run this, we can see that small x did join concatenate with the capital Z, which we have here at index 0. So all the elements within those series were concatenated based on their value of index, not the position where they were physically. So it's based on the value of the index. Again, as you can see, the presence of NaN creates removes the NaN that may be present, like the accompanying value that could be present in instead of NaN for that same index in other series. So here, if we again use Na underscore replace is equal to hyphen, we can see that we now have the capital X as well, which is as index 3, and that is paired here with the Na or NaN of at index 3 from the series A. So we have the hyphen X. Now here, as you probably have guessed, we can try all combination. We can try inner combination here, we can try outer, we can try inner, outer, we can try right, and these are the same type of concepts that we looked in previous videos, where we are trying to join two data frames and merge two data frames. So here it's as simple as what we are getting. So if we look at the right, when we are doing a right join for the A and B, our A series, so the B is, which is this one with a new index x, y, z and q, so that appears here on the right hand side, and you have the x that is appearing on the, which is the A that is appearing on the left hand side. So you have the x, y and z shuffled by the indices in which the B data frame B series is located. So the indices for B is 3201, and that's what we have in the output 3201. Whereas when we did the left join, the indices were in the order which was for A. So that was what we have for how we can join by index. Now moving on, what happens if we have the series that have unequal lengths? How do we manage that? So if there are unequal lengths, let's create a series C, which is pd.series, and here we can give it a couple of values, v, and let's say w, and then x, y, and then z, so z, and again the same index. So we can say index is equal to, we'll give some index 9, 8 that are not there in other series, and then index 0, 1, 2 that we have in the other series. So that's a new series that we are creating here, and see, this is how it looks. Now we can join this series to A. So A is equal to, if you remember, A has A looks like this. It has xyz from 0 1 2 3. Now if we do str.cat, and within a list we want to specify B and C, and then we are going to go ahead and join is equal to outer, and na underscore replace is equal to, within quotes we want to specify hyphen. And here we can now see that we have the original x y z and blank, which was a nn. Then for B we have the accompanying z q y and x as we expected. And for C, now C has these two values at index 9 and 8, which are down here, and those are arranged 8 and 9 in order, like sorted. But then those two values, though indices, are not there in series A and B, and therefore because we have given na underscore replace is equal to hyphen, therefore we have the two hyphens placed here. And again the value for x, that is for index 3, is not there in the series C, therefore that is going to be blank, and therefore we have a hyphen there on the right side of capital X as well. That's it for this video. In the next video we'll talk about regular expressions, and then probably either in that video or further video we'll see how we can use regular expressions to work with strings in pandas. I hope you are learning a lot of new things up to this lecture. Please like, share and subscribe. It helps me stay motivated to create more content for you guys. And also please check out the other series, real world applications of data science. I hope you are enjoying those too. And also the exercises that I've put up for, I think, up to first 6 or 7 videos. If you like them, please let me know. Thank you, and I'll see you all in the next video.